So next topic will be on wheat ecology. In this lecture, I will touch more on the concept of wheat ecology and why is it important. Some fundamental concepts that I hope you can grab along this part 1 and subsequent videos. Basically, I will expose you to the adaptive mechanisms of wheat, how human influences to wheat ecology. Then in part 2, we will discuss some concepts of ecology and how environment interact to wheat. And finally, in part 3, I will discuss on plant or wheat competition, especially the effects of weeds on crop yield. I hope you can learn from this 3-part video about the importance of ecological relationship to wheat management. I want you to know and understand the wheat crop ecosystem with wheat environment interactions and wheat crop association and relate them to wheat management. In wheat competition video, I hope you can grasp the idea of plant competition and understand the characteristics that make wheat competitive. What is wheat ecology? I'm sure by now you are already familiar with the concept ecology. Ecology is the study on interactions between organisms with their environments. So wheat ecology differs only in that the organisms being studied are wheat. These fundamental ecological concepts are something that I assume you guys already in your fingertips. If you forget, open back your first year note and try to understand these concepts, or just Google them. Understanding this is important because all discussion after this will be based on these concepts. So why is wheat ecology important? Why we need to study them? In this video, I will tell you 3 stories about how human intervention have influenced wheat ecology in this world. First is the story of the white settlers in United States. When the first settlers came to United States Great Plains and parts of the Pacific Northwest, they found blue bunch wheatgrass and black seed needlegrass dominating the sites of wagon trails. When roads were cut, downy brome invaded and dominated roadsides. The onseeds are very rough and dangerous to the equine, to the horses. This species is actually an introduced species in USA. When chemical weed control became available, roadsides were sprayed with the triazine herbicide, simazine, to control downy brome. Simazine worked well, and because it persists in soil, it prevented reinvasion of downy brome and other grasses. However, it does not control sandbur, which became the dominant species on many western roadsides. Next is the story of caribou weed. The story of caribou weed is a story that I like the most. This story is about how humans think that they can outsmart the nature. Caribou weed is basically the giant salvinia or Salvinia molesta. It is an aquatic plant that can infest rice field. The story started when the government of India wants to increase the production of rice in Kerala. They found out that the rice fields are very close to the sea and salt water decreases rice production. Traditionally, farmers had built soil barriers to prevent seawater to come during growing season and remove them after harvest. The so-called expert built a spillway channel to control seawater entrance to the rice field. The channel worked and the salinity of rice field significantly reduced. Then, what happened? Because the seawater has never entered the rice field, Caribou weed reinvade the rice field and stopped rice production. The engineers were very good at building structures but knew nothing about weed ecology, and the weed won. The third story is about weedy rice in Malaysia, something that I study very closely. In early days, rice production in Malaysia is all about muscle and pain. Transplanting, less mechanical, labor-intensive and very traditional. However, the agriculture practices changed, especially in the early 80s, where direct seeding method was introduced. This method reduced time and labor to produce rice. The production can be twice a year rather than once before direct seeding. The mechanization also improved where more machinery and technology were introduced. Of course, we want to be a developed country, so we must be like one. No weedy rice have ever been reported prior to 1980s, so I can assume that rice field in Malaysia has never been infested with weedy rice until the introduction of direct seeding method. Various theories have been reported about how weedy rice emerged. Please read the paper I've posted for further reading. In general, weedy rice has taller stature than cultivated varieties and only can be differentiated at maturating stage. The most effective control of weedy rice is by rogging, where the weedy rice was removed prior their seed maturity. This practice is very laborious and time-consuming. The story of weedy rice in Malaysia is getting worse. In 2006, as part of my master degree, my supervisor and I discovered that weedy rice grow as tall as other cultivated rice, or what I called they stand among equals, make it harder to identify and recognize. They possessed other weedy characteristics, but not taller stature, including easy shattering, red pericarp color and on. So now, how we can control weedy rice? Rogging is no more can be used to cut the weedy rice because it's hard to identify now. So what can we do? The evolution, if I may call it, is very short, only within 25 years. So, what do you think? What else can weedy rice turn into? Weedy rice evolve and always be, no matter how we change the cultivation practices, control methods, they will try to escape. What are the nature of their ecological adaptation? This is something I've been working on for more than 10 years now. So weedy rice always evolve. The only thing that not evolve is my tummy. Haha. And we are now towards the implementation of herbicide-tolerant crops. We already have one in rice. Or how about GM crops? Are we ready for that? Are you ready for that? How weeds respond to these ecological changes? Have we already considered that? Again, I throw this question to you. Why weed ecology is important?